Hello and welcome to this next session on basic electrical repairing. Now in the next couple of videos, we will try and understand joints. What are joints? Joints are essentially ways in which you can connect different wires together. Many a times when you are working on electrical lines, there is a necessity for you to make joints. You will need to make joints because number one, there could be a disconnection in a particular wire and you may need to join those two wires to ensure that the supply is restored. Two, many a times when you are working on setting up new electrical lines, you may fall short of wire and you may need to extend the line with a joint or adding another wire to it through a joint. So these are some of the common reasons why you will need a joint. There are different types of joints that exist. In this course, we will talk about two specific joints called a straight joint and a T-joint. Now, to demonstrate a straight joint, we are going to be using a 3-core 20-gauge wire. This is called as a 320 wire in the market. The 3 represents the 3 cores that you have in the wire, and the 20 represents the thickness or the gauge of the particular wire. And we talked about the thickness and the identification of wires in one of our earlier videos. So this is a 320 wire, which basically means 3 cores and 20 gauge wire. So we will be using this wire to demonstrate a straight joint to you in this video. Now we will use some tools here. One of the tools that's required is emery paper or sandpaper. This is primarily used to remove any carbon in the cores, to ensure that you are able to solder them properly. So we will use the sandpaper to remove any carbon. We will also use something called as a wire stripper. This wire stripper is used essentially to remove the insulation from any wire. You can also use this to cut wire, but most often than not, this is a very good tool to be used to remove the insulation from any wires. Now we use a wire stripper here because when we are removing the insulation, we don't want the inner wire to be disconnected, and that's the reason why we will be using a wire stripper to remove the insulation material from this particular wire. Then we will also be using a soldering wire. This will be used to solder it. A soldering wire is essential primarily because once the joints are made, we will have to solder them to ensure that they are there for longevity purpose. And we will be using a paste, which is a soldering paste. This is to ensure that we solder it very well and extend the soldering properly across to all parts of the joint. So we will use the soldering wire and the soldering paste, and finally we will be using the soldering iron as well to ensure that we are able to melt the soldering wire and place it on the joint and seal the joint. The soldering iron is placed in a stand which comes along with it to ensure that it's easy for you to store it and use it whenever you're working with a soldering iron. We will also be using an insulation tape. We learnt about insulation tape in one of the previous videos. So once we make the joint, we solder it and then we will finally put the insulation tape on it to cover the entire joint. So these are the tools that we will be using to do the joint or to make the joints. First of all, in order to make a straight joint, ensure that you straighten off the wire clearly. And before you do anything else, you'll have to measure the wire to ensure that you take adequate quantity wire or adequate length of wire. Here we are going to be using roughly around 4 inches of wire. So we will need 4 inches of plain wire, which means there should be no insulation for up to 4 inches. So we are going to remove the insulation up to about 4 inches using the wire stripper. So while you are using the wire stripper, be very careful because if you press it too hard, it may cut the entire wire. So we use it very lightly to cut only the insulation part across on all the sides. So you slowly press it around the wire and then you can hold it from the other end and pull out the insulation out. So make a small cut on the insulation so that the insulation alone is cut out, and once the insulation is cut properly, you can slide out the insulated part by holding the wire onto the other side tightly. As you can see, the insulation will easily slip away using the wire stripper. Now this way you will ensure that the inner conductor material or the core is not damaged and this wire is not cut off at any point. So we've removed the insulation for about 4 inches in this, and then we straighten out each of these cores. They need to be exactly straight because then it will help us in joining them very easily. And once we straighten it out, we will ensure that we intertwine the wire for up to 1 inches from the insulation part. So we've already created one such wire. Now we're going to make the joint in the second wire. So we'll measure about 1 inches and twist the wire for up to 1 inches from the insulation part. Now we do this twisting to ensure that the wires are tightly placed. This will ensure that there are no sparks, because typically loose wires can result in electric sparks, and electric sparks are more commonly the reasons for fire to happen in residential premises. So when you tighten them and ensure that the spirals are tightly placed, you are eliminating the possibility of an electric spark within the wire. So for about 1 inches, we have twisted the wire together, and that leaves us with the top portion which is open. Now straighten out the top portion very clearly and then fold them to the side. So flatten them out like this. So this looks like a small 3 branches of a small tree. So 1 inch of twisted part, and then the remaining part is slightly folded. And we've done the same thing with the other wire also, where we have tightened it for about 1 inches, we have intertwined it, and then we keep these two parts together to join them. Now before you join them, you need to use the emery paper to remove any carbon on any of these. Carbon is something that will prevent you from doing a proper soldering of these wires. So we're going to use the emery paper or sandpaper to rub off any carbon there, and once you remove the carbon, you will be able to see a little bit of shining on each of these wires. And you need to do this in both the wires before you actually join them together. So because of the insulation material on top, there could be some residual carbon which is left out on these wires. So this carbon can be removed by using the emery paper or sandpaper. And once you have done that, again straighten them out, and now they are ready to be joined together. You place one wire on top of the other, connecting them at the center so that the 3 arms fit into the 3 other arms. So they overlap one between the other 2, and then we slowly start bending the wires in a clockwise direction. So you roll them out in a clockwise direction, ensuring that they are joined properly. So we hold the top 3 parts and then start rolling it out across the joint. As you can see, we're going to slightly roll each wire into, and do it one by one to ensure that it's tightly wound around the joint. So it's now tightly wound around the joint, as you can see. Ensure that there is no gap while you are doing this. And you can do it one by one. Do the first wire, and then the second lead, and then the third lead. So all 3 cores are tightly wound across the twisted portion or the intertwined portion. Very clearly you can see it on the screen. It's very tight, and you are pressing it hard to ensure that it fits in place. Be careful of your fingers while you're doing these, because some of these wires could be very sharp and can cause physical injury. So be very careful while you're twisting it around. So once you have done this, cut off any extra part using the wire stripper. So we've removed any unwanted part and now it's tightly wound. So typically in a straight joint, you would be able to see that the 3 wires on top are now tightly wound. Now we need to do it on the other side of the wire as well. So just as we did it on top now, we will do the same thing on the bottom portion of it to ensure that it's tightly wound around in the bottom portion of the wire. So typically a joint is very critical because whenever you're working on power line, it's recommended that you don't use any joint. You need to ensure that you measure the exact length of wire and ensure that there are no joints in between. But if there is a necessity for a joint, you need to ensure that the joints are tightly wound. This will ensure that the connectivity is intact and the wires don't break very easily. Many a times if joints are very loosely made, they can lead to loose contact and can result in open circuitry and more faults. They can also cause sparks which can result in a fire hazard. And that's why it's important to ensure that you have the joint tightly made and properly made. And in a straight joint, the connections are really very strong. So we have tightened it from the bottom side. Remove out any excess wire. And as you can see, this joint is absolutely strong now. So even if you pull it apart from both sides, this joint will not come out. So that is the reason why a straight joint is probably the strongest joint that you can ever make. And this is very, very critical when you're working on the electrical line. Now, this is not the end of it. We'll also learn how to do soldering and covering this later in one of the videos. Keep watching, keep learning. Thank you very much.